Now welcome to the heart of HUICA, the chapter 6, the solution inside my dissertation. First, what is Hierarchical User Interface Component Architecture, in short HUICA? Well, it's a component-oriented software architecture for rich client-based user interfaces. It's based on a strong separation of concern, and this is achieved through an orchestrated hierarchical composition of stateful components, which themselves implement the user interface through independent, hierarchically communicating, model view separating, and data binding driven dialogues. If we go one step deeper, HUICA consists of mandatory core, strong recommended base, and optional but useful plus building blocks. Those building blocks you can see here on the left side. This ranges in the core from the hierarchical component structure, the hierarchical component states and hierarchical component communication, towards the hierarchical dialog composition and hierarchical dialog architecture, to data binding of presentation model and business model. Then on the base side, this is complemented through user interface aspects and user interface ontology, a component tree structure patterns and component tree behavior patterns. And finally, on the plus side, HUICA adds user interface runtime monitoring and user interface runtime integration. This as a whole is what HUICA, the Hierarchical User Interface Component Architecture, is about. Now let's step into the individual parts. The first is the user interface aspects. Here HUICA defines the essential user interface aspects every UI should have, because the technology stack later especially has to completely cover them. The aspects are grouped into mask, data, connectivity and dialog parts, and if you look carefully you see it's the whole range of user interface aspects one is usually talking about. This ranges from interface theming to widgets, layouts, effects, interaction, state, mask and the environment detection, to the data binding, data conversion, data model, data caching, up to the business model and business model communication, and finally on the whole dialog side we have dialog structure, lifecycle communication and dialog navigation. The point of HUICA is that the dark brown ones are often overlooked in practice, and this is especially the case if you check the particular UI libraries and frameworks on the market. You will see that they cover more or less just the lighter brown aspects, and the darker brown aspects are very often overlooked. But HUICA makes a focus on all of them. The second point is the user interface ontology. This ontology is actually the big picture of HUICA, because it provides a view how the user interface specification on one side correlates with the user interface component tree and this particular coding of the UI here shown on the right side. In particular, on the user interface specification side, we have storyboard. This consists of wireframes and areas, and on those areas we have various interactions to go from one area to another area or even to a whole new wireframe. If you know tools like Balsamiq, you know this world of user interface specification through wireframes and interactions very well. The next point is that HUICA classifies various user interface fragments we know about. So we have first user interface composition, where the user interface is consisting of various fragments, and those fragments are now classified first into composites and widgets. The composites themselves are classified down to panel and dialog composites, and the widget are classified down to container, controls and visual widgets. The point is that later in HUICA we implement this user interface through controller, model and view components, and composites always consist at least of a controller component and optionally of model and view components, while the widget are implemented through mandatory model and view components, but just optionally through a controller component. Then HUICA talks about hierarchical component structure, because in HUICA we directly map the hierarchical nature of user interfaces onto a tree of object-oriented components. This tree can be shown in HUICA later in the natural order, where the root is at the bottom and the leaf components are at the top. And it can be also in the traditional component tree visualization, where the root is at the top and the leaves are on the bottom. In HUICA, I personally prefer the natural component tree ordering, because this has a major advantage. If you take the user, and the user is always at the top of all diagrams in architecture, and this user looks on or projects from his eye onto the component tree, what he actually sees is a flattening of this natural component tree visualization, because you first see the leaves, and around those leaves there are the middle components, and at the outmost you see the root component. Another point is that HUICA treats this tree like a file system. So it has a little bit of a query language, which is very similar to a Unix file system path, where you can select particular components, as you see here at the bottom left side, through various path specifications. This can be an absolute path, or it can be actually scan a whole full subtree. It can be relative, it can use wildcards, and a lot of more things. And this is actually the flexibility of HUICA in the implementation side. That is, one can more or less treat the components like files on the file system. Then a user interface is inherently stateful, though HUICA then at the next aspects has hierarchical component states. The first point is, you see it here on the top left, in HUICA, in the component system, component.js later, we can first define particular states all our components should have, and for each state we can define the operation to go into the state, so entering the state and leaving the state. The life cycle of a component then over time, here at the bottom from left to right, consists of just state transitions. Though the component is first created, it's configured, it goes to prepared, materialized, visible, ready, and later back again to perhaps visible, materialized, prepared, and configured. HUICA now states that there are two important invariants on component states, which a component system like component.js, which implements HUICA, has to ensure at any time. Invariant 1 here shown on the right top is stating that at any time each component can only be in either the same or any lower state than its parent component. And invariant 2 says at any time each component can only be in either the same or any higher state than its child components. What does it mean in practice? These are very important invariants for a user interface. Let's take the example of a user interface implemented by a particular component tree here shown on the left top side. We have a root component at the bottom and a leaf component, here 6, on the top. And if we take this particular path from component 1 over 2, 3, 4, 5 to 6, we take this path from root to leaf and rotate it just counterclockwise once. Then we have those 9 diagrams, these 9 steps in the middle. In each of those diagrams, this path from 1 to 6 component is now shown. And the point is that the root component is on the right, the leaf is on the left, and from bottom to top we have the different levels or the different component state levels. So in step number 1, component 1, the root, is at the highest component state, and component 6 it's at the lowest state. Now imagine what happens if in step number 2 the component number 5 should be increased to a higher state, usually done programmatically by triggering a state transition. Now this would actually mean that in step 3 component 5 reached a situation where its parent components 4, 3 are at a lower state. This is not allowed because the invariant state said that at any time each component can only be in either the same or any lower state than its parent component. You can also imagine the situation optically in a user interface, because imagine that component 5 implements a dialog and component 4 is the outer dialog. So this dramatical situation in step 3 would actually mean that the sub-dialog implemented by component 4 is visible, while the outer dialog implemented by component 4 is not. So it would be floating around without its outer panel. This does not work, and that's the situation why step 3 is actually not allowed by the component system. Instead, what happens in step 4 is that before component 5 goes up, first component 4 has to go up, and in turn, before this can happen, component 3 has to go up. So we are actually reaching then step 5, where everything is still holding the invariant number 1. Similar for the invariant 2. If we imagine that in step 6, component 3 is forced or triggered to go into a lower state, we would happen that in step 7, actually, we would got a situation where component 3 breaks the invariant 2, which says at any time each component can only be in either the same or any higher state than its child components. Here, once again, the component system of HUICA will kick in and says, wait, before we can actually drag down the state of component 3, we first have to drag down the state of component 4, and before this actually can happen, we first have to drag down component 5 to a lower state. So we finally reach the step 9, where everything is still holding. This is what HUICA states and what the HUICA compliant component system, for instance like component.js, have to enforce at any time. So whatever you are actually triggering, an increase or a decrease of a state of an arbitrary component, the component system has to ensure that those two invariants always hold at any time. Additionally, a HUICA compliant component system has to provide two additional features related to component states. The first are state guards, the second are resource spools. On the left you see a particular code snippet from a dialog which showcases the state guard. Here in a prepare step, the component system is initialized by setting a render guard to the value 2. And then two resources are fetched from an external URL, and in each step the guard is decreased by 1, and the effect is that the render function is executed once both URLs were actually loaded. So this is actually like a semaphore in computer science, but on the level of user interfaces. And the second feature are resource spools. Usually you see it here on in the snippet on the right top, and you have a prepare function where you actually allocating a resource, and in the corresponding release function you are actually destroying this resource. The problem is that allocation and deallocation are at different positions in the code, while actually your thinking during programming is that once I allocated a resource, I know best how to deallocate it later. And what you actually can do, you can spool this deallocation, or here this destroy operation onto a spool. And the point is that once you spool things up, they get actually executed in the reverse order once the spool is unspooled. This is an important thing if in a user interface you're actually allocating more and more resources, you can deallocate them in the reverse order during runtime. The next aspect of HUICA are the hierarchical component communications through properties, models, sockets, events, and services. The essential point here is that all those communications are really done hierarchically. So similar to the DOM in the browser, for instance, if an event is published, it is actually published in a hierarchical fashion along the path of the component tree. And similar for other things, when we are looking up properties or model fields, this lookup always happens along the path from the particular component up to the root of the tree. Then in HUICA there's the aspect of hierarchical dialog composition, because a user interface inherently is a hierarchy. So it makes sense to hierarchically decompose a user interface into a component tree where each component, or at least a triad of components, implement particular user interface fragments. This decomposition is a highly creative act because the result is highly unambiguous. Nevertheless, a few dimensions can be taken into account. For instance, the visual similarity of the user interface fragments play a role, the technical granularity, the separation of concerns, and the brackets created by particular use cases. Here in this example, you see at the top left a particular mock-up of a user interface consisting of two menus, an outer toolbar and a status bar, and a few of detail dialogues. And it can be decomposed into various ways. Here in the middle bottom you see one variant of the decomposition, and at the bottom right you see another variant. Both are neither wrong or right, they are just different flavors of the same decomposition. Then in HUICA there is the aspect of hierarchical dialog architecture, where we actually model the user interface through the help of a triad of components in a component tree. This triad of components is based on the model view separation patterns, and in particular model view controller, as we will see later. The first point is that this view, model and controller components are always in a strict order inside the tree. There's always a view at the top, there's always the controller at the bottom, and the model in between. So it's actually not MVC, it's more or less VMC in HUICA. When it comes to the knowledge the components have of each other, the controller actually has just a black box knowledge about the model and the view, more or less because this triad is instantiated usually through the controller component, and hence this controller component needs to know the view and model. When it comes to a white box knowledge view, the controller knows the details of the model because it has to provision data into the model, and the view also has a white box knowledge view about the model because it has to react through a data binding on the values in the model. So this is actually not a layering. This is an important point. Yes, it is drawn like layering, but it is not a classical layering as in software architecture where the upper layers know about the lower layers but not vice versa. Finally, as we have already seen in the ontology, there are two variants of this component triad. One variant is for composites, where the controller component is mandatory and the model and view components are optional. And the other variant is the widget triad of components, where the controller component is actually optional while the model and view are mandatory. Now let's have a look how this model view controller components are actually implemented. The heart of the solution is the model view controller component tree pattern. This is actually a variant I created of the model view controller pattern for use in HUICA. We see now on the left an arbitrary tree of components. As mentioned before, we have always this order. The controller is at the bottom, the model in the middle, and the view is on the top. But there are multiple variants there, as we will see later. If we now zoom in, we get the view, model, and controller components, here shown in large in the middle, plus a component from the service layer. The service layer is not part of the user interface, but we placed it here at the bottom of the diagram to be able to connect the data flows to the controller. In the next step, we add logical layers to the architecture. The view component gets the two logical layers, view mask and view binding. The model component gets the two logical layers, presentation logic and presentation model. And the controller consists of a single logical layer, the presentation control. And the service component gets the business service logic layer. Now let's add aspects into those layers. First, on the view mask, we have just a single aspect. This is the view mask itself. But on the view binding, we have mask rendering, command binding, state binding, data binding, and event binding. These correlate directly to aspects in the presentation model, which is parameter values, command values, state values, data values, and event values. In the middle, we have an aspect, presentation logic, directly fulfilling the functionality of the presentation logic, and the presentation control layer gets the two aspects, presentation provisioning and presentation actioning. The business service layer gets the two aspects, business model and business logic. Now let's zoom in once again onto the model, controller and service layers and see how the data actually flows. Well, it starts at the controller. The presentation provisioning usually gets the control and calls the business logic to fetch data from the business model. The presentation provisioning then puts those data into the parameter values, command values, state values, and data values aspects of the presentation model. Then the particular presentation model values through the data binding aspects in the view binding layer are transferred to the view mask, and through observer patterns in the view mask we can get the data back. The first lane is through the data binding. Data can come back to the data values, and especially through the event binding, data can also come back into the event values. Please notice that also modern UIs always have an event binding to react on interactions in the view mask. Usually code is directly executed. In HUICA instead, we just remember the information in the event values. Once values arrive in the presentation model aspects, the presentation logic aspect can kick in. Usually this is done in case command values, state values, and data values or event values trigger something and the result are new state values and new data values. This is very important because the presentation logic in HUICA is neither part of the view nor the controller. It is directly part of the model. This is important because later this allows HUICA to drive a UI completely headless. In case state data and event values arrive in the presentation model, the presentation actioning can kick in and decide to either trigger once again the presentation provisioning for the next round or update the business logic and this way the business model. To sum it up, this is what hierarchical dialog architecture is about. It's not just about having view, model and controller components in a tree. It's also how these components actually are laid out through aspects and the communication, data and control flow. With this diagram, which is really central to HUICA, one can drive model view controller on a component tree. Actually, all aspects and all data and control flows directly relate to individual code snippets in practice. Nevertheless, on a logical point of view, we can also contrast this new model view controller component tree pattern to the original model view controller from the 80s. Here on the right side, I've once again shown the original diagram as shown before, and on the left side, I've created a new diagram of model view controller component tree, which just logically shows how this pattern actually works. In this contrast to model view controller, we see that model view controller component tree has distinct changes to model view controller. The first one is there's this distinction between presentation model and domain model. We see that model view controller is actually triggered or controlled from the view component, while in MVC-CT it is the controller who drives everything. We see that in model view controller component tree there's a data binding and a lot of more things, including the fact that in model view controller component tree both the view, model and controller all have this notion of the parent controller, parent model and parent view. In this way know about the hierarchy. Finally, in contrast to model view controller, in model view controller component tree, input and output devices are all located just at the view component, and this way the view component actually can play the role of a so-called negligible view. The next aspect of HUICA are the data binding of presentation and business model. There are different approaches HUICA defines. On the presentation model side, there can be the clean approach of a declarative external mapping between the presentation model fields and the mask. Here in HUICA, I defined a particular domain-specific language which allows to map this in a similar fashion to CSS, but instead of styles for the values. The pragmatic approach in practice usually is to embed a little bit of a mini language like Vue.js into HTML, and this way we have a pragmatic approach through a declarative inline expression-based approach. This is very similar to the data binding on the business model. Here we also can have a data binding in a clean approach with a declarative external mapping, which is a little bit unusual in practice. The pragmatic approach is once again a declarative inline expression or query-based approach where, for instance, Facebook GraphQL is used to bind information from the backend to the business models inside the front end. The key to a real data binding of a business model is not just this query language. Instead, it is the recognition on the server side when a query result would have been changed, and this way the query is re-executed on the front end side. The next aspect of HUICA are the component tree structure patterns. Because as we have seen before in the diagrams, there is not always just view, model and controller inside the tree, but there exists variants, and these are defined by HUICA in various patterns. There is first the alternative view, where multiple views exist for the same model. There's a reusable widget consisting just of a view and a model. There's a standalone controller just consisting of a controller. This in practice is usually combined with a usable widget to form a whole dialog. There's this headless pair of just consisting model and controller components, usually done in the middle of the component tree for driving a subtree. And in case of no special demand, there's the full triad of view, model and controller components. The other part HUICA does on the pattern side are component tree behavior patterns. There are patterns like controller created descendant, interaction event values, presentation state logic and own descendant communication, but also this central and important pattern common ancestor communication. This is really one of the most important ones because it creates what separation of concern is about in a user interface. To understand this, just imagine an arbitrary UI consisting of a so-called master detail dialog. So you have an outer dialog and inside there are two dialogs. One is the master, one is the detail. And if you select, for instance, elements in the master, for the selected element on the detail dialog, an information is shown. So usually you can just attach an event listener on the master side and directly trigger through a method call an operation in the component of this detail dialog, but this is not what separation of concern is about. Instead, what should happen is that you should use events or model values to transfer this information from the master to the detail dialog. And this has to go to the common ancestor dialog, which is the outer dialog. So in practice, with events, it has to mean that an event bubbles down from the master to the common ancestor dialog, and then it goes upwards again into the tree for the detail dialog. The same can be done with model values. Then a common ancestor model is used for transferring the information. The essential point here is that neither the master nor the detail dialog know that they are actually working together. The only dialog which knows this is the common ancestor dialog, because this is the dialog who has the controller who established this whole subtree in practice. The next aspect of HUICA is the user interface runtime monitoring. This means that HUICA says that an underlying component system should provide a visualization what the component tree actually looks like in real time. We see here an example. On the left we see a particular application, and on the right we see the component.js component system and its runtime debugger to visualize the underlying components of this particular application. But HUICA doesn't stop here. It also gives an idea how runtime monitoring can be extended further by actually providing constraints onto the runtime behavior of the application. This is important because a component system like component.js later allows more or less arbitrary communications on a tree, but from an architecture point of view, those communications should be constrained. HUICA defines here two things like a peephole constraint and a temporal constraint. The peephole constraint can be, for instance, something like a view has to conduct its plug operations when it is in the materialized state. And the temporal constraint can be something like value expects an observe beforehand, otherwise it would be useless. We actually created a component.js plugin which provides exactly this information through a domain-specific language to formalize those constraints. Then we have in HUICA user interface runtime integration. Here HUICA talks about how third-party UI fragments can be integrated into HUICA-based user interface. This can be done through the component tree, through iframes and other aspects.